Okay, welcome everybody to lesson 17 of the 2022 to 2023 session. It's almost the end of the school year. This is the Education for Nepal English group. And this is our YouTube channel for past lesson recordings. If you want to watch stuff, click on this link right here. First icebreaker of the day. What is your favorite song or album? Feel free to type in the chat or just unmute and speak out. Or if you don't have a favorite song, you can say like your favorite genre or songs. Like what's your favorite category of songs? No, does no one like music?
For me, I like piano and classical music because it's really calming. Do anyone else want to share?
Oh, we got a piano player here named Leo Zhang. Leo, share your favorite music.
Yeah, I really like piano music, man.
Damn, okay, you should play your piano live sometime.
I should.
Okay, what's your next icebreaker? What's your favorite ice cream flavor? Chocolate, vanilla? Okay, we got some answers. Personally, I like chocolate more than vanilla. Start with biology, and then we'll teach pop culture. Oh, no, sorry, we'll do astronomy, and then we'll end off with pop culture. So in biology, we're doing cellular respiration and photosynthesis. Gracia, do you want to start it off?
Okay, so we're going to start with photosynthesis. And in the image on the right side, that's the equation of photosynthesis and cellular respiration. But we'll get to cellular respiration a little bit later. And basically the equation for photosynthesis is the opposite of cellular respiration. So the reactants in one of the processes are the products in the other. And both of these help to sustain life on Earth, and both are important parts of the Earth's carbon cycle. So next I'm going to be talking about the chloroplast, and this is where photosynthesis occurs. And the chloroplasts are an organelle in plant cells, and they contain chlorophyll, which is a light absorbing pigment. And this is why when you look at plants, they're green. And the two stages of photosynthesis are, the first one is the light dependent reactions, and the second are the light independent reactions, which is the Calvin cycle.
I just want to clarify one thing. Chloroplasts are green not because they absorb green, but it's because they reflect green. They actually absorb red along with other colors, but they mainly like to absorb red. But they reflect green light, which makes them green.
Okay, so the light-dependent reactions in photosynthesis is when the chloroplasts capture solar energy, and then the solar energy is converted to chemical energy, and water is converted to oxygen that is released as a byproduct of the light-dependent reactions. And then for the light-independent reactions, they use the chemical energy produced from the light-dependent reaction to convert carbon dioxide into sugar molecules, basically glucose.
Okay. I'll cover cellular respiration. So earlier we talked about photosynthesis, which makes glucose. Now we're going to talk about how the cell or the organism uses the glucose to actually make usable energy. So cellular respiration is the process by which cells break down glucose and other food molecules in the presence of oxygen that releases energy. It has a total of 3 cycles: glycolysis, the citric acid cycle, also called the Krebs cycle, and the electron transport chain. So the really important equation is at the bottom of the screen. It's C6H12O6 which is also known as glucose plus oxygen, turns into carbon dioxide plus water plus ATP, which is energy, plus heat. So this is like the overall equation for cellular respiration. And yeah, you can see how it's like oxygen and glucose goes in and then carbon dioxide comes out. So like when you breathe. So the first part of cellular respiration is glycolysis. This occurs in the cytoplasm of the cell, which is like the liquid part of the cell. And it's anaerobic, which means it doesn't require oxygen. And then this step breaks down glucose, and you make from the glucose, you get 2 NADH, 2 ATP, and 2 pyruvate or pyruvic acid. An image is shown on the right to like help you visualize the process. And as you see, it goes from glucose to pyruvic acid into lactic acid, but that's not too important. But you can just see that overall ATP, NADH, and is being made. So the next part is the Krebs cycle. This part occurs in the mitochondrial matrix, and it's aerobic, which means it actually requires oxygen now, because cellular respiration overall requires oxygen. This one, you convert the pyruvate, which was made earlier in glycolysis, into carbon dioxide and 8 NADH, 2 FADH2, 6 carbon dioxide, and 2 ATP. So yeah, you also get a net gain of 2 ATP from the Krebs cycle. Now the final part is the electron transport chain. This is the part that makes the most ATP. So the electron transport chain occurs in the mitochondrial inner membrane and is also aerobic. And this uses the energy stored in NADH and FADH2 to ultimately make a lot of ATP. And the final electron receptor is oxygen. What that means is that as the electron goes through the chain, like oxygen it ends up with the oxygen at the end. And then you make approximately 32 ATP here, which is like a lot more than we said before, because earlier we're making 2, now we make 16 times that. So this is the part where like most of the ATP is made. So another way cells can also make ATP or energy is called fermentation. Fermentation is another anaerobic non-oxygen part. So this one does not require oxygen, unlike cellular respiration, which requires oxygen for breaking down glucose. So fermentation recycles NAD plus from NADH when there's no oxygen. And then there's 2 types of fermentation here. One of them is lactic acid fermentation, which is done by your muscle cells. So when you exercise a lot, you consume a lot of oxygen, but at the same time, your muscle cells can also undergo fermentation to produce like quick energy. And you make lactic acid as a waste. And then alcoholic fermentation, this is done by yeast for like, how you put in like bread, or like, how like alcohol and like wine and stuff can ferment. And you make ethanol and carbon dioxide as waste. And the overall process is shown on the bottom there. So why do cells usually choose cellular respiration over fermentation? It's because although fermentation doesn't require oxygen, fermentation produces way less ATP than cellular respiration, and cells would just like choose to perform the process that makes more
hi,
ATP.
Vincent. Sorry
Yeah.
to interrupt, but like a student talked about that in the chat, that could you speak slower or teach slower? So like maybe explain further. Or just speak slower. Yeah.
Okay, my bad. If you have any
Okay.
questions, you can like send it in the chat. If you have any slides you want to re-go over, you could also send that in the chat. So fermentation is not as optimal as cellular respiration because it produces way less ATP, and it's like if you have the option to produce more, you would always choose to produce more. Now, is there any questions? Because I know it's going a bit fast. Okay, then I'll just summarize it in general. So in general, plants undergo photosynthesis, but humans and other animals obviously don't. So plants undergo photosynthesis and they make glucose in photosynthesis, and that glucose goes to your mitochondria, which is in your cell, and then your cell undergoes cellular respiration, which has three parts. The glycolysis, the Krebs cycle, and the electron transport chain. And through these three parts, you turn the glucose into the ATP as shown in the equation on the bottom. And that ATP can be used as energy to power your body, because as you know, like whenever you're doing something, you need energy. Like if you don't have any energy, you know, you'd be like tired or you want to go to sleep or something. And yeah, and in general, the electron transport chain produces majority of the ATP, whereas the glycolysis and citric acid cycle, they only make 2 ATP each. And fermentation is basically the way cells make energy when there's no oxygen, but it's not chosen like as people usually cells usually don't choose to undergo fermentation, but they can go cellular respiration because fermentation produces way less ATP. Okay, if there's no questions, then we'll go on to astronomy.
All right, today we're going to be covering manned space missions. So I guess we'll start with Sputnik, which is basically the first man-made satellite that was ever launched in history. It was actually made by the Soviet Union, rather than like the US, which is usually considered like the frontier of astronomical missions. Basically what happened was it was constructed on October 4th, 1958, or launched there at that time, and it caused a space race between the USSR and the US. And the creation of Sputnik is pretty interesting, actually. It occurred after World War II, when basically the Soviet Union at the time and the US was able to get their hands on German missile technology. And they originally were trying to research it for creating intercontinental ballistic missiles, which would basically allow their nuclear warheads to attack each other across the world. But instead, it was able to like branch off into astronomy, and since it could go into space, and eventually it created Sputnik, which is the first satellite. It stayed in Earth's orbit for 22 days and orbited the Earth 1,440 times, and it traveled around 70 million kilometers total. All right, and next important space mission would be the Vostok 1. It's actually another Russian space mission, and this one is like basically sending the first human into space. It just sent one person, who is Yuri Gagarin, I think, and yeah, it just completed one full orbit of the Earth in 108 minutes. And on the right, you can see he actually had like a video of him like televised, and then there's a model of him or his spaceship in some museum. And then probably the most famous mission, Apollo 11, space. This one was done by the US. Probably heard of it. It's the first mission which landed humans on Mars. Consisted of a crew of 3, who's Neil Armstrong, of course, the first human on the moon, Buzz Aldrin, and Michael Collins. The entire mission lasted 8 days, 3 hours, 18 minutes, and 35 seconds. And on the right, you can see pictures. It's only Buzz Aldrin on the moon because there's not that many pictures of Armstrong on the moon, because he's actually the one that took most of the photos.
Okay, so next we have Apollo 13. And this was the 7th crewed mission in the Apollo space program, and the 3rd mission meant to land on the moon. The Apollo 13 launched from the Kennedy Space Center on April 11th in 1970. And although it was supposed to land on the moon, the lunar landing was aborted after an oxygen tank in the service module failed 2 days into the mission. So the crew had to loop around the moon in a circumlunar trajectory, and they safely returned to Earth on April 17th. The mission was commanded by Jim Lovell, with Jack Swigert as command module pilot and Fred Hayes as lunar module pilot. Next is the Mars rover. And this was actually not a space mission with a crew, but it was actually, as you can see, a Mars rover. And a Mars rover is a motor vehicle which is designed to travel on the surface of Mars. And there are several advantages of rovers over stationary landers. So the first one is that they can examine more territory. The second is that they can be directed to interesting features. The third is that they can place themselves in sunny positions to weather winter months. And the fourth is that they can advance the knowledge of how to perform very remote robotic vehicle control. Last is the Voyager 1. And the Voyager 1 is a space probe that was launched by NASA on September 5th in 1977 as part of the Voyager program. And it was meant to study the outer solar system and interstellar space beyond the sun's heliosphere. The Voyager 1 was launched 16 days after its twin, the Voyager 2. And the Voyager 1 has been operating for 45 years, 8 months, and 13 days as of today. And it communicates through NASA's Deep Space Network to receive routine commands and to transmit data to Earth.
We're moving on to the final section of the day, which is pop culture. And today we're doing movies.
All right, yeah. So as Vincent said, we're gonna do movies. So first off, what are movies? So movies are a work of visual art that encourages ideas, stories, perceptions, feelings, etc. So earlier films were basically just stationary shots or pictures that were taken from different angles and eventually put together to make a scene. And later films, obviously, there are higher quality cameras, and music and color were added to help enhance the quality of movies. There's also a lot of different types of films, including action movies, adventure movies, comedy, drama, and horror, to name a few. So our first movie for today is Harry Potter, which is obviously based on the Harry Potter novel written by J.K. Rowling. The movie talks about a boy named Harry Potter who goes to Hogwarts, which is a school for wizards. There are currently 8 total Harry Potter films, and it is also the 4th highest grossing film at $7.7 billion.
I have one comment.
Yeah,
Technically, isn't the 8th movie a play?
yeah, you could say that. But it's all right. It's all right. It's still 8 films. It's all right. Okay, and then the next movie is the Minions movie. So Minions are just small yellow pill-shaped creatures which have existed since the beginning of time. Gru is the master of the Minions. So there are 6 total movies in the Minions series, with Despicable Me being the first movie released in 2010. And some of the themes are good over evil, family, and community. And here we have the movie Shrek, which is a Disney produced fairy tale story, and it has 4 current movies released. It is an hour 30, and the first Shrek movie came out in 2001. It takes place in a swamp where an orc named Shrek is invaded by fairy tale creatures, which causes him to make a deal with Lord Farquaad. And as a result, he goes on a journey to rescue Princess Fiona in exchange for clearing the swamp.
So it's it's by DreamWorks Animation, and it's an hour and 37 minutes. And it came out March 31st, 2017. And it's a movie and a TV show. I think it's like 2 or 3 seasons. And basically it's told from the point of view of a 7-year-old, and he got a younger sibling. And it's said that it's his imagination, and the movie itself follows his imagination and follows like the baby, boss baby, and he's like on a mission, and the movie is about his mission to like get the love back from the puppies that are taking away the love from babies. And then the TV shows have like other missions, or like each season follows another mission that the boss baby has. Yeah.
Okay, that's it for this week. If you have any questions, you can unmute yourself right now, send in the chat, or that's it. We would appreciate it if you could fill in this form right here by clicking on this link. And this would give us feedback on how to improve our lessons and what we should teach next time. And yeah, thank you guys for coming.